Hello, Dr. K. Please let me explain my homework 5.2. It's from Labview. Okay, now the title of this research is Embedded Counter System. Okay, so this is contents. The first one is research objectives. The second is research content. The third one is hardware connection. The fourth is implementation process, and the last one is conclusion and acknowledgements. So you can see the picture on the right. It's about this objective of this research is to create an embedded content system with bidirectionally counting capability 0 to 22 0 cycle and visual status indication using LEDs, demonstrating key embedded system design principle. Okay, so this is main content. So the master hardware implementation of finite state machine in resource constrained environment, and understanding parallel procession and timing loops, Labview Labview data flow programming advantage, and achieve developing of human machine interaction and system state via visual indicators, and construct robust timing logic for stable counting frequency, immediately state transition, and reliable output. This is develop hardware in the loop debugging and verification skills through LED and count observation. So the overview you can see is integrated project components, software algorithms for counting logic, hardware interface design for LED control, and finite state machine implementation for state management. So the bidirectional counter design implement cycling counting 0 to 22 0 with automatic direction resolve at boundaries 0 and 20. Then is analyze an internal variable to track current counting direction, directly dictating LED display logic. Okay, so you can see this one. What we need is state indication logic, implement materially inclusive LED display, LED 1 on doing increment, LED 2 on doing decrement, using condition structures, ensure real-time response. Labview and hardware interface is design digital output group control for independent LED addressing, and implement precise timing using time loop or while loop with wait function. Okay, the hardware connection. We should how do you connect this system? The core hardware setup consists of an NIDAQ device with its digital output port connected to two LED and the circuit detail. Each LED is paired with a current limiting resistor to protect both the LED and the DAQ output channels. This forms a complete, safe electrical circuit for reliable bidirectional counting status indication. We can see the system, computer, and IDAQ device, two LED, and correcting limiting resistance. R1 and R2 is equal to 330 ohm, and a connection to digital ground. So the key components is the 330 ohm resistors are critical. They ensure a current of approximately 10 amp flow through the LEDs, provide optimal brightness while protecting both the DAQ port and the LED from damaging due to excessive current. So the identification output port is assigned LED1 to port 0 line 0, LED2 to port 0 line 1. So then we should connect the LED. Put the line 0 to LED or not, line 1 to LED2 or not, and cast node 330 resistance to ground. The correct limiting resistance is 330 ohm. Then we just put the common ground. So the implementation process, there are two main phases. One is front panel design, and one is block diagram design. So is the numerical display a current count values indicator to show the count within the 0 to 20 range, and the status indicators, two around LEDs labeled LED1 status and LED2 status to visually mirror the hardware LED status. Then the control element, a start-stop button to initiate and hit the counting system operationally. Then lay out a clear and logic arrangement of all 11 elements for intuitive operation and monitoring. So the conclusion, the project successful implement a bidirectional embedded counter system with visual LED indication. The key achievements include master FMS hardware implementation, parallel precision, state decoupling, robust timing logic, and hardware in the low debugging. Demonstration practice embedded system design skill use Labview and DAQ hardware. Okay, that's all. Thank you for your listening.